Hi everyone, this lesson is for Algebra 2 Honors students. We are covering matrices today, which is Chapter 4, Day 5. So let's get started. Our learning objectives are that students will add, subtract, and multiply matrices. Also identify the identity matrice for a 2x2 and a 3x3. So just getting started, we have a matrix, and a matrix is it's a rectangular array of rows, which are horizontal, and columns, which are vertical, meaning this right here would be row 1 and row 2, and this would be column 1, column 2, and column 3. Each one of these numbers here is actually called an entry. This matrix right here, matrix M, we call these row by column. So that's how you say it. You say it row by column. And then, so this is 2 rows. So this is a 2 by 3 matrix. So that's how you say a matrix. The dimensions of these matrices are basically, again, row by column. So that's row 1, row 2, row 3, and that's row 4. This is column 1, column 2. So this matrix, A, would be called a 4 by 2. And this one right here, we have 1 row, we have 2 columns, column 1, column 2. And so this one is called a row by column, so it's called a 1 by 2. This is a row 1, row 2, so we have 2 rows, so that's a 2 by column 1, column 2, column 3, column 4, and column 5. So that's a 2 by 5. Now, the interesting things about matrices is that when you are adding and subtracting matrices, you can only add and subtract matrices that have exactly the same size. So with this 4 by 2, I would need another 4 by 2 to add it. Or if I have a 1 by 2, I would need another 1 by 2 to add or subtract, okay? So again, adding and subtracting matrices, they have to be exactly the same size, exactly the same dimensions. So what we have here is we're going to be adding these matrices. So as you can see, the first one is a 2 by 2, row 1, row 2, column 1, column 2. That's a 2 by 2. And I want to add another 2 by 2. So if I'm adding a 2 by 2 plus a 2 by 2, then the only option for me to have is a 2 by 2. So this is a 2 by 2, 2 rows, 2 columns, 2 rows, 2 columns. So if I have a 2 by 2 and a 2 by 2, then I can add those. And ultimately, when I add my 2 by 2 matrices, I'm going to get a 2 by 2. That's my only option. So you're going to add each of the entries exactly where they are. So for example, 5 is going to be added to -8, okay? So 5 plus -8 is -3. -7 plus -3 is -10. 4 plus 4, that's 8. And then 6 plus 0, which is 6. So I'm done. That's it. Adding matrices is kind of fun. This right here, this is a row 1, row 2. So that's a 2 by, what is that? A 2 by 1, 2, 3, 3. And I want to add that to a 3 by 2. And guess what? I can't do that. This one is definitely not possible. And the reason is like I said several times, when you're adding and subtracting matrices, you have to have the same dimensions, the exact same dimensions, okay? Because every entry that you add has to be added to a likewise entry from the other matrix, and they have to coincide, okay? Now, or correspond. I will say this though. Even though the addition or subtraction of these 2 matrices is not possible, I will say this, that if I have a 2 by 3 and I have a 3 by 2, I actually can multiply them, okay? And this is the trick. If these 2 values inside are the same and I'm multiplying my matrices, then the result, okay, will be what's left, which is the 2 by 2. And so when I multiply a 2 by 3 times a 3 by 2, I'm actually going to get a 2 by 2. Okay, these don't count, they just have to match. And so we're going to be multiplying matrices in just a minute, but remember that, okay, for then. We are going to be performing the indicated operations. So this is plus, this is minus. This is a 3 by 3, remember, a 3 by 3 and another 3 by 3. It has to yield another 3 by 3, it has to. So that has to be a 3 by 3, so you just write it like that. and then add the numbers. You've got 3, each entry gets added. It's very simple. 3 plus 6, which is 9. 12 plus 7 is 19. 1 plus 0 is 1. 1 plus 1 is 2. 6 plus 3 is 9. 5 plus 1 is 6. 3 plus 4 is 7. 5 plus 5 is 10. And 5 plus 3 is 8. So I'm done. And that's just very simple, finished. Subtraction is a little bit trickier, but I mean, no less difficult, just because the margin of error just raises just a little bit because of the minus sign in the middle, and some kids forget to subtract a negative, and that's just a little bit of an error. You have 4 minus 5 again. You line everything up, everything has to correspond. 4 minus 5 is going to give me a negative 1. 6 minus negative 1 will be a 6 plus 1, which is a 7. 8 minus 1 is another 7. 2 minus 3 is a negative 1. You have a 2 minus 5, which is a negative 3. Negative 2 minus 6, negative 8. Negative 4 minus negative 2. So that's negative 4 plus 2, which is a negative 2. 0 minus 2 is a negative 2. And 9 minus 10 is negative 1. And then you're done. You've got a 3 by 3, 3 by 3. Remember, you can only add or subtract like dimensions of matrices. So 3 by 3 is going to yield a 3 by 3. Now, they are going to be a little bit tricky occasionally. And so for like example, in this problem right here, we have a 2 by 3 and a 2 by 3. They're slightly different though, right? So we have a 2 by 3 and we have a 2 by 3. And our job is to do this. This is what the directions say. So I'm going to take negative 3a and subtract 3b. So that means that I actually have to take negative 3, and this number right here, we call that a scalar, S-C-A-L-A-R. Scalar number is just a number. We call that scalar. So that's going to be negative 3 times a, which is negative 2, 4, 4. 4, negative 4, negative 1. And I'm going to subtract 3 times b. b is that other number. So 2, 4, negative 4. Negative 4, 1, negative 4. So we have 3 times this is a minus 3 times b. Well, let's see what we get. We're not solving anything. We're just simplifying and performing the operation. So I'm going to actually multiply that through first. And I'm trying to decide if I want to subtract or add, at the beginning or end. Do I want to multiply through by negative 3? Or do I want to multiply by 3 and then subtract? So actually, I'm going to multiply by negative 3 and then end up adding these. Hopefully, that's less margin for error. So here we go. Negative 3 times negative 2 is 6. Negative 3 times 4 is negative 12. Negative 3 times 4 is negative 12. Negative 3 times 4 is negative 12. And negative 3 times negative 4 is positive 12. Negative 3 times negative 1 is 3. So then I'm actually multiplying by negative 3 to every value inside of my matrix. So negative 3 times 2 is negative 6. Negative 3 times 4 is negative 12. Negative 3 times negative 4 is positive 12. Negative 3 times negative 4 is positive 12. Negative 3 times 1 is negative 3. And negative 3 times negative 4 is positive 12. And so I have a 2 by 3 plus a 2 by 3, and that's going to yield another 2 by 3. And now I just have to add the corners. So 6 and negative 6, that's 0. Negative 12 and negative 12, well, that's negative 24. Negative 12 plus 12, 0. Negative 12 plus 12, 0. 12 plus negative 3 is 9. And 3 plus 12 is 15. And so therefore, this right here, this final matrix is negative 3a minus 3b. So it's not hard, it's just a little tricky. Now this one is a little different. I see it says simplify. Actually, this should say, oops, we don't want that. Actually, this should say solve. And in solving this right here, what you see is a 2 by 2 equal to a 2 by 2. So if you have a 2 by 2 equal to 2 by 2, then they should equal each other, right? So what you're doing basically is you're setting each one of these equations equal to each other, right? And ultimately solving for x and y, meaning the values that are in the same position or entry are the exact same. So this one says x plus 1, right? Well, that has to equal 11. So x plus 1 has to equal 11, which means x equals 10. So this means that in my 2 by 2, right, it's a 2 by 2, then that means that x has to be 10, so there's a 10 here. We know that's 11, right? And let's see, what else do we know? We know that y plus 1, so we have x is 10. So we know y plus 1 equals 3. So y equals negative 1, or sorry, if I subtract 1 from both sides, I get what, 2? So this right here is 2. Oh, or obviously, look at this. Y is equal to 2. I could have just seen that right there. So, so for this problem right here, all you had to do, I mean, like, you definitely can, you know, set it up as a matrix, but that's not what they're trying to ask you to do. All they're asking you to do is solve for x and y. So we know that x is now 10 and y is 2. And I hope you noticed that I did that a couple of different ways. You know, y is equal to 2 just by looking at the entries, or y plus 1 should equal 3, okay? So again, for this problem, this one right here just has to do with what you see in here. This was like from 1984 Olympics, bobsled ride, and that was just like a movie that came out with that. But regardless, so in 1984, we had Brazil and Jamaica. Jamaica had 3 golds, 0 silvers, and 1 bronze. And Brazil had 2 gold, 1 silver, and 4 bronze. And in 1988, similar. So what happens is, to add and subtract 2 matrices, of course, they must have the same rows and columns, right? And that's called the same dimensions. And in order to get those dimensions, again, you would just make sure it's a 2 by 3 plus a 2 by 3, and that's going to yield me a 2 by 3. So that's going to be 3 plus 1, which is 4, 2 and 1, and this will be 2, 3 plus 1 is 4, and 4 plus 1 is 5, and then I'm done, okay? Now, I know, Alexander, you were asking me about this, so this is what I was talking about, how you're going to be seeing this later. So we saw this matrix of Olympic medals, right, on the previous slide. What if we wanted, though, to weigh the different types of metal differently, okay, like gold and silver and bronze? So meaning I want to yield 5 points. I want to award 5 points for gold, 3 points for silver, and 1 point for bronze. So how is that going to help me at all, right? How do I do that? So these are my application type of problems that Alexander was asking me about. And so this is how you would actually do it for the weights of the different metals. So 5, 3, and 1. So for this, you've got 5 for golds, 3 for silver, and 1 for bronze. And so this value right here, so we are going to take our gold values and times those by those values right there to weigh them differently. Now, the way you multiply matrices, and this is like I was saying on that previous slide, remember, this is a 2 by 3, and this is a 3 by 1. And the key is that these two values inside have to be the same value, which they are, check, so I'm going to not use those. My result, though, is what's left, a 2 by 1. And so remember, it's a row, right, by a column. And so row by column. So I've got 2 rows. So 1, 2, and then I've got 1 column. So I've got basically row 1, right, row 2, and then I've got column 1 column. So this is how you're actually going to multiply. This is how you're going to multiply matrices. Okay, so it's kind of tricky. So if you kind of take your finger and you multiply across, that right there, okay, that's your row. So you're going to be multiplying your row by your column at the same time. So you're going to go row by column. Now, another way of doing that is to think, well, I need to so I'm going to multiply row 1 by column 1. And when you're multiplying these values, you are multiplying and adding in between, okay? So this is what you're going to do. Basically, it's going to be 3 times 5. So you're saying 3 times 5 plus, see, this 3 times 5. So this is going across, and this is going down. So I'm going 3 times 5 plus 0 times 3. So 0 times 3, 0 times 3 plus, and then 1 times 1. So 1 times 1. And so for that one, that's row 1, column 1. So this is row 1, column 1. I'm going to get 15 plus 0 plus 1, which is 16. Okay. So then the next one, for the next row, I've got row 2, column 1. So this is row 2 gets multiplied by this column, by column 1. Okay. So we're going to go 2 times 5. So you're going to go across for the rows and down for the columns. So this will be 2 times 5 plus 1 times 3 plus 4 times 1. And that is going to be 10 plus 3 plus 4. So that's 10 plus 7, which is 17. So this is going to be 17. Dun, 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 dun. So we multiplied our matrices. Awesome. So now we have a 2 by 3, and we're going to multiply that by a 3 by 2. Now remember, the insides have to match. Check. Done. We're done with those. And so what's left is going to be this value times this value. So that makes a 2 by 2. So we've got a 2 by 2. Now, this is row 1, row 2. This is column 1, column 2. Now, you don't have to write those at all, but you can just think about them, right? So we're going to be multiplying, see this? To get this spot right here, we're multiplying row 1 by column 1. We're multiplying row 1 here by column 1 here, okay? That's how you do that. So we're going to go multiply across, and we're going to add those values together. So we're going to go 1 times 1 plus 0 times 3 plus negative 2 times 0. And what is that? 1 plus 0 plus 0. That's 1. So this value is 1. So now I want to find this spot right here, which is row 1, column 2. So I'm going to go row 1, which I already circled, and now I want to multiply that by column 2. Okay, so it's like this. One line goes across, one line goes down. So we're going to go 1 times 2, so 1 times 2 plus, right, this row by this column. So I'm going 1 times 2 plus, and now I go 0 times negative 1. So 0 times negative 1 plus negative 2 times 1. Negative 2 times 1. So for this spot right here, which is row 1, column 2, I have 2 plus 0 minus 2. That's 0. Okay, so let me erase that so we can put some numbers in here. So this, what I get? 2 plus 0 plus negative 2 is 0. Okay. And I think this was a 1. Okay. And so, so now, we now want to find row 2. We want this spot. So that's row 2, column 1. Okay, so I'm going to erase this just to clear it up for everybody. So now to find this spot down here in the corner, I have to multiply row 2 by column 1. And so this is row 2, right? Row 2 by column 1. And so again, each number with this, it's like going to multiply by each other. So we're going to go 2 times 1 plus, see, 2 times 1 plus 1 times 3, that's this 1 times 3, plus 1 times 0, so 1 times 0. So that's 2 plus 3 plus 0, which is 5, and that's a 5. Okay. Lastly, for this problem, okay, we are going to go this value to get this value here, which is row 2, column 2. So we're going to go row 2, which is this row, rows go across, and column 2, which is this column, like that. So we're going to go 2 times 2 plus 1 times negative 1 plus 1 times 1. So that's 4 minus 1 plus 1, 4. So my 2 by 3 times a 3 by 2, remember these have to be the same, yields me a 2 by 2, which there's my answer. So my answer is 1, 5, 0, and 4. So I hope you like that. That's kind of cool, right? Okay, so these are 2 more. I'd like you to just try these. just to make sure that you're able to multiply the matrices. So I'm going to do them, and I prefer that you would pause the video right now so that you can try them yourself. And this is a 2 by 2, and multiplied by a 2 by 2 is going to yield me a 2 by 2. So that's for this one. This is a 2 by 2. And then this one down here is a 2 by 3. And then this is going to be a 3 by 2. And that's going to yield me another 2 by 2. Okay, so take a minute, pause the video, and then do those, and then come back. So I'm going to assume that you're back. And so we're going to work on this. These are my rows, and these are my columns. So to find this value in the front, on the top, that's going to be row 1, column 1. So that's going to be row 1 this way times column 1. So that'll be -3 times 6 plus 5 times 1. So going across. So that's going to be -18 plus 5, which is -13. So that's -13. So for the next value, okay, we're going to go for this spot on the right. We're going to say this is row 1 and column 2. So we're going to go row 1 times column 2. So that's going to be -3 times -2 plus 5 times -5. So that's 6 minus 25, which is -19. So that'll go there. For the next problem over the next value down here, which is row 2, column 1, right? Row 2, column 1. Row 2 times column 1, we're going to go -2 times 6 plus 1 times 1. So that's -12 plus 1, which is -11. For the next value, and the last value for this problem here, we need this spot down here, which happens to be row 2, and this is column 2. So this is row 2 here times column 2. So that's going to be -2 times -2 plus 1 times -5. So that's -4 minus 5, which is -9. And so that's my 2 by 2, and we're done. For this problem here, this also is going to give me a 2 by 2, but it's a little bit trickier because I have a third, column or row. In this case, the 3's are going to cancel. But remember, it's still row 1 times, for this spot right here, which is row 1 and column 1, we want to multiply these terms, row 1 by column 1, okay? So we're going to go 1 times 7, 7, 1 times 7, I'm just going to write 7, okay? So 1 times 7, which is 7, plus 2 times 9, which is 18, plus 3 times 11, which is 33. So 33 plus 18 plus 7, get that stuff going, 33 plus 18 plus 7 is going to be 58. So this value here is 58. So now I need to do for this column, I need to go row 1 by column 2. So this is going to be this column here. So we're going to go 1 times 8 plus 2 times 10 plus 3 times 12, okay? So what's that? 36, 46, 56 plus 8, 64, and that's going to be this value right here. For the bottom row, we're going to erase this and the column, and then we're going to go, okay, now I want this row 2 times column 1, right? Row 2, column 1. So I want this row and this column. So we're going to go 4 times 7, which is 28, plus 5 times 9, which is 45, plus 6 times 11, which is 66. So I'm going to go 66 plus 45 plus 28, and that's 139. So that's this little corner right there. And then this last spot is row 2 times column 2. So that's going to be row 2 times column 2, which is this column here. So we're going to go 4 times 8, which is 32, plus 5 times 10, which is 50, plus 6 times 12, which is 72. So we've got 12 times 6. We've got 72 plus, 50 plus 32. How many is that? 154. So, and that's 154. So that's my that's it. That's my matrix multiplication for the 2 by 2. Wow, okay. Now, just a note, we have something called an identity matrix. So similar to the multiplication matrix, like 5 times 1 is going to give me 5. That would mean 1 is my identity for multiplication. And then if I was thinking for the identity for addition, that would be 0, right? So any number plus 0 gives you the identical number, which is 5. So the identity for addition is 0, and the identity for multiplication is 1. So the identity for a matrix is 1, 0, 0, 1, which means that if I were to, that's for a 2 by 2. For a 3 by 3, see the ones, they're the diagonals. They just go down like that, and everything else is a 0. So if I were to multiply a 2 by 2, which is this value here, by my identity matrix, then I should get the identically same matrix, right? So let's try that. Let's just make one up and say 1, 2, 3, 4. And I'm going to multiply it by its identity matrix, which is 1, 0, 0, 1. And a 2 by 2 times a 2 by 2 is going to yield a 2 by 2. And then again, you're going to multiply row 1 by column 1. So 1 times 1 is 1 plus 2 times 0, which is 0. So 1 plus 0 is 1. And then I'm going to go across for this spot. So we got 1 times 1. We've got, let's see here, wait, this times this and this times this. So yeah. Okay, so 1 times 0 is 0 plus 2 times 1, which is 2. So this number is 2. And then I'm going to go this row by column 1. So that's going to be 3 times 1 plus 4 times 0. So that's 3. And then I'm going to go this row here by this column. So 3 times 0 plus 4 times 1. So 3 times 0 is 0 plus 4 is 4. So if you see that this identity matrix here, because I multiplied by the identity matrix, then I should get the same exact value, just like an identity for multiplication, okay? And lastly, you have an identity element for a 3 by 3, and just know you can multiply these out and see how you get, if you multiply by the matrix like this, which is the identity element, which is basically 1 in a matrix language, and Keanu Reeves would know all about that, but 3, 2, 1, and then, right, 3, 2, 1, and everything is going to be exactly the same in an identity matrix, okay? So you have an exit ticket tonight, Wednesday, and I assume that if you need to review something that you should go back, but reviewing our learning targets, you guys have covered addition, subtraction, and multiplication of matrices, and also a couple of little tricky situations in there, as well as the identity matrix for a 2 by 2 and a 3 by 3. So thanks for watching, and good luck on your exit ticket.